Hey everyone, in this video I'm going to talk about the vector databases and I'm going to give you a brief demonstration of how you can set up the Pinecone account and perform different CRUD operations on it. So a vector database is a type of database optimized for storing, indexing and retrieving vector data. The most common example of a vector database is Pinecone database. Pinecone is a cloud-based vector database service that is specifically designed to handle high-dimensional vector data efficiently. There are three main components of the Pinecone database. First one is the index, then we have the namespaces, and the third one are the vectors. So, in Pinecone, an index refers to the data structure that enables efficient searching and retrieval of vectors. The index is optimized for high-dimensional data, allowing for fast querying even in large datasets. Namespaces in Pinecone provide a way to organize and group the vectors. They are like containers that allow you to separate different sets of vectors within the same Pinecone environment. Each namespace operates independently and vectors within a namespace are treated as a distinct set. And then finally, we have the vectors. In Pinecone, vectors are the core representation of data. A vector is a mathematical entity that encapsulates the features or characteristics of a data point in a multidimensional space. These vectors could represent a wide range of data types such as images, text, or numerical features. Let's start the action. So the first step is to sign up for the Pinecone account. You have two options. Either you can go for the paid version or you can select the free tier. I'm gonna go with the free version. So once you click on it, you will land on a page that looks something like this. You have different options. Either you can continue with Google, with GitHub, with Microsoft, or if you scroll down, you can also subscribe through a cloud marketplace. Right now, I'm gonna continue with the Google. Then you have to select the account with which you want to sign in and it will ask you to sign into the process. Click continue. After that, a pop-up like this will appear that will ask you to enter some information about yourself. So it will by default fill your first name and the last name on the basis of your provided email address. Then it will ask you for the company name and then it will ask you to provide your goal. Then select any of the options for what are you making and for your preferred coding language. I'm going to select Python because in this tutorial we are going to be using Python. Then simply click on complete setup. And once you do that, you will land on the page that looks something like this. This is actually the home page of the Pinecone dashboard. Here on the left hand side, you can see the navigation menu having indexes, API keys, members, docs, and other settings. Right now, we are on the indexes page and you can see that there is no index currently available and it is giving us an option to create the index. But we are not going to use this option. We are going to create the index and perform all the operations using Python in the PyCharm IDE. But you have to remember that since we are working on the free tier, so the free tier only allows you to create one index and a limited number of functionalities are available for it. So you cannot create multiple indexes in the free tier. Now let's see how it actually works. Head to your IDE. In this video, I'm going to use the PyCharm IDE. And let's move towards the second step, which is to import the Pinecone client. And you have two options. Either you can include it using the pip command from the terminal, or if you want to select it from the Python interface, then go to the files. From here, you have to click on the project settings. And once you land on this page, you have to click on Python interpreter and click on this plus sign. Once you do that, here you have to type Pinecone client and this is the library that you need to install. I have already added it into my project, so I'm not going to do it again. But you have to click on this library and then click on this install package button which is present right here. And once you have successfully imported the library, now we are going to import it in our project as well. So I'm going to say import Pinecone so that we can use all the features of this library here in our test.py file. Now let's move towards the third step, which is to get the API key. Whenever you want to establish a connection with the Pinecone, then you need to have the API key and the environment. So let's head back to our Pinecone dashboard. And from here, you can see that we have the option of the API keys on the left navigation menu. Click on it and you have a default API key available. You can also create a new API key, but I'm going to go with the default one. So from here, you can copy the key value and you also need to remember the environment. So the environment is GCP starter. These two things will be needed when we will create a connection with the Pinecone. Let's head back to our IDE. Now we are going to move to our fourth step, which is to actually establish the connection of our IDE with the Pinecone. And for that, you have to use pinecone.init function inside which you have to pass two parameters. The first one is going to be the API key which we have just copied and the second one is the environment. So now in place of API key, I'm going to paste the value that I've just copied. And for the environment, you remember that the environment was GCP starter in my case, and you can write the environment name which is present on your account here in the environment. And once you do that, we have successfully connected our project with the Pinecone. And in order to verify it, you can also run the project to see if there are any errors or not. Alright, so the project finished with exit code 0. This means that there are no errors and we have successfully connected our project with the Pinecone. Now I'm going to move towards the next step, which is to create indexes. As I've mentioned earlier, that indexes are used to store the vector embeddings. And inside each index, the vectors share the same dimensionality and distance metric for measuring similarity. And in order to create a new index, I'm going to use pinecone.createIndex function that takes 3 parameters inside it. So the first parameter is going to be the name of the index with which you want to create it inside the Pinecone. The next one is going to be the dimension, and the third one is going to be the metric to perform the nearest neighbor search. So here I'm creating a new index by the name test index that performs nearest neighbor search using the Euclidean distance matrix for the 8-dimensional vector. So once this is done, now in order to test whether the index has actually been created or not, I'm going to print the pinecone.describeIndex function, and inside the index name I am going to pass test index. And this is being done to ensure that the index by this name has been created, and it is going to give us information about the newly created index. Now let's go ahead and run it. Okay, so it says that index name must consist of lowercase alphanumeric characters. So I am gonna change it to test-index. Now let's run it again. Alright, so the process finished with exit code 0, and it has provided us the index description saying that the name is test index, metric is Euclidean, replicas are 1, dimension is 8.0, shards are 1, and there are other information about the index. Now let's verify whether it has actually been created in our Pinecone dashboard or not. So let's head back to our Pinecone dashboard, and from here I'm gonna click on indexes. Right now there are no indexes available. Let's refresh it again, wait for it to load, and yes, you can see that a new index by the name test index has been created here as well. But right now there are no records inside it. So this takes us to our next step, which is to insert the vectors inside our index. And for that, let's head back to our IDE. And here we are going to start by creating different vectors and inserting them inside our index. Since we are going to use the test index again and again, so in order to refer it, firstly, I am going to create a client instance that targets the test index. And to do so, I'm going to create a new variable index, inside which I am going to pass pinecone.index, and inside the index function, I'm going to pass the name of my index, which is test index. So in this way, we have created a client instance that targets our index, and whenever we want to target this instance, we'll simply refer to this index variable. And you have to remember one more thing, that we need to comment out these lines because we don't want to create index again and again, and it will not allow us to create multiple indexes also, since we are working on the free tier. So if you do not comment out these lines, then whenever you want to run the project, it will throw us an error that only single index can be created. So make sure that you comment out these lines in case you are working on the free tier. Now let's actually insert the vectors inside the index, and for that I'm going to use the index.upsert function. So whenever you want to insert the data inside the index, you have to use the upsert function. Inside the upsert function, I am passing two things. First thing is a dictionary by the name vectors, and this dictionary has two key value pairs. The first one is for the ID of the vector, and the second one is the values, which is again a list of different values for the vector. So in this way, inside this index, at once I am inserting 4 different vectors by creating a dictionary of vectors having ID and values. And then the next parameter is the namespace. So as I've discussed earlier, that namespace let you partition vectors within a single index. So instead of having all the data inside a single index one after the other, you can actually partition your data into different chunks on the basis of different namespaces. So I've created a new namespace by the name ns1. And similarly, I am going to again use the upsert function, inside which again I am going to pass a dictionary of vectors having ID and value, and this time all these vectors will go inside my namespace which is ns2. So in simple words, I have partitioned my index into two namespaces, each containing 4 different vectors. So overall there are 8 vectors inside the index which are partitioned into 2 different namespaces, right? Let's verify that if we have successfully created the vector and inserted it into the index or not. Let's run this project to verify it. Alright, so the process finished with exit code 0. This means that all of these codes have run successfully. Now in order to verify it, let's head back to our Pinecone dashboard. Let's refresh the page, and now you can see that the vector count is 8. This means that 8 new vectors have been successfully added inside our index. And you can see that here it says that we have 2 namespaces which are the ns1 and ns2, each having a total of 4 vectors. Now if you go to the browser, if you select the namespace ns1 and if you query it, it is going to show you all the 4 vectors which are present inside this namespace. And if you change this ns1 to ns2 and you query it again, then you will see that it is going to give you the 4 vectors which are present inside our ns2. But collectively, all of the 8 vectors are present inside our test index. Okay, so we have successfully inserted vectors inside our index. Now let's see how we can actually fetch the data of these index in our IDE. So let's head back to our IDE. So in order to fetch the vectors inside our index, we can use the index.fetch method, and inside it you have to pass the IDs of the vectors whose value you want to print on the IDE. So let's say I want to print out the vectors whose ID is vec1 and vec2. So I can write it in the form of list like this. So inside the list, so firstly you have to pass the ID of the first vector and then the ID of the second vector separated by comma and so on. So in this way you can pass any number of vector IDs you want to fetch and display its record on the ID. So right now I only want to display the data of the vector 1 and the vector 2. So I've placed their IDs inside my fetch function, and I'm going to pass all of this inside the print function so that I can print the values which are returned by the index.fetch function. But before that, I have to comment this upsert function again because we don't want to insert the same rows inside our index. So I'm going to quickly comment out these lines, and now I'm gonna go ahead and run the project. Okay, so it has given me nothing in place of namespace and the vectors. This is because I haven't provided the namespace name. So outside the square bracket, here I'm gonna paste the namespace name which is ns1. So now I want it to fetch the vectors having ID vec1 and vec2 from the namespace ns1. Now let's go ahead and run this to see how it responds. Okay, so now it has fetched the correct data. The namespace is ns1. And for the vectors having ID vec1, these are all the values. And for the vector having ID vec2, these are all the values which are present inside the vector. So in this way, you can fetch any number of vectors you want. You simply have to pass the namespace name with the vectors if you have multiple namespaces inside the index. But if you have all the data inside the index without any namespace, then you don't need to provide the namespace as a second parameter. You simply have to pass the list of vectors whose data you want to fetch and display. Let's move one step further. Now, I'm going to show you how you can actually update the data which is present inside the vectors. So, there are actually 2 ways of updating the records inside the vector. First one is the full update and the second one is the partial update. So, a full update modifies the entire record, including the vector values and the metadata. And updating a record by ID is done in the same way as inserting the records. So this is done using the upsert function of the index. So whenever you want to fully update a vector, which means that updating the vector values as well as the metadata, then you have to use the upsert function and provide the ID of the vector whose values you want to fully update. So let's see an example. If I want to update the index having ID 3, and now instead of ID 3, I'm gonna say vec3 because this is the ID in my case. So let's say I want to fully update the vector having ID vec3 to these 2 values, then I'm gonna use the index.upsert function and pass the index ID and the new values with which you want to update the vector. And this upsert function is going to update vector values as well as the metadata of the vector. So in simple words, whenever you create a new vector inside the index, you use the upsert function and provide the ID. But whenever you create a new vector with the upsert function and provide the ID which is already present, then all the data which is present inside the index having that vector ID will be overwritten by the new data which we have just added. So in this case also we already have a vector by the ID vec3. So when we try to create a new vector by the same ID, then it is going to update it fully with these values including the vector values and the metadata. Let's go ahead and run this to see how it affects the vectors. Okay, so it is saying that vector dimension 2 does not match the dimension of the index 8. Okay, so here instead of 2 values, we have to pass 8 values. Now it should work fine. Let's run it again. Okay, so the process finished with exit code 0. Now I'm gonna head back to my Pinecone console. Let's refresh the page to have the updates here as well. Okay, so apparently the values haven't changed, and yes, this is because I once again forgot to define the namespace. So here outside the list, place a comma, and inside the double quotes, you have to provide your namespace name, which is ns1. Now let's run it again, and it has successfully executed. Let's go back here, refresh the page. Alright, so you can see that now for the vector having ID vec3, the values have been updated to the newly added values inside the upsert function. And not only the values are updated, the metadata for this vector has also been updated. So this was the full update. Now let's see what is the partial update. So the partial update allows you to change the single part of a record. It can either be the values of the vector or the metadata of the vector, or you can also update both at once. And the partial update is done using the update function. Since we are not using the upsert function, so the entire vector will not be changed and only the value that we passed inside the update function will be changed. It may be either the vector values or the metadata or both. So let's see an example. What if we only want to update the vector values? For that, we are going to use the index.update function. For the ID, we are going to pass vec3, and in order to update the values, we'll pass a list having different values. So now if I will run this, it is going to only change the values of the vector having ID vec3 and not the metadata. Once again, I forgot to mention the namespace name. So here instead of simply providing the namespace name, you have to pass namespace here and then provide the value of the namespace. Let's run it again. Now let's go ahead and verify it from the console. Let's refresh it, scroll down to see the vector having ID 3, and yes, these are the values that we have just updated using the update function. So we have performed the partial update. This means that only the vector values have been updated and not the metadata. And you can verify it by seeing that there is no metadata here. Now let's see another example in which we are going to update the vector by updating its metadata. And for that, once again, we are going to use the index.update function. I'm going to provide the ID of the vector, and then I'm going to use the set metadata to set the metadata of this particular vector. So I'm going to set the type to be web, and the value of new is going to be set to true, and the namespace name is ns1. Now let's see if it will only update the metadata for us or not. The process finished with exit code 0. Now let's head back to our Pinecone console. These were the previous values, and right now there is no metadata. Let's refresh it. Scroll down to see the vector 3, and yes, you can see that now in place of metadata, we have the 2 values which we have just added inside this vector by using the update function. So in this example, we performed a partial update on the vector in which we only updated the vector by changing its metadata and not the values. And similarly, you can also update the vector values and the metadata at once inside a single update function. After learning about how you can update the vectors, let's see how you can actually delete the vectors inside our index. So there are 2 ways of deleting the vectors from the index. Firstly is to delete any particular vector by providing its ID and the namespace, and the second one is to delete all the vectors at once which are present inside a single namespace. So I'm going to show you both ways of how you can delete the vectors. So in order to delete the vector, you are going to use the index.delete function. Inside it, you have to provide the list of the vector IDs which you want to delete, and then you also have to provide the namespace. So right now I want to delete the vectors having IDs vec1 and vec2 present inside the namespace ns1. Let's see that if these vectors will be deleted or not. Okay, so the process finished with exit code 0. Let's head back to our Pinecone console. Let's refresh this page to see the new values. Let's scroll down and you can see currently we are in the namespace 2 if we select the namespace 1 and click on query button. Right now, there are only 2 vectors available. So previously, we had 4 vectors inside this namespace having IDs vec1, vec2, vec3 and vec4. But the vectors having ID vec1 and vec2 have been deleted and only these 2 vectors are present inside the namespace ns1. So this was the first way of deleting particular vectors from the namespace. The next way is to delete all the vectors of a particular namespace at once. And in order to do so, once again, I'm going to use the index.delete function. And inside it, I'm going to set the delete all to true and then provide the namespace. So now it is going to go inside the namespace having name ns1 and we'll see that we have set the delete all to true. So it is going to delete all the vectors which are present inside the namespace ns1. Let's change it to ns2 so that we have 2 vectors in the namespace ns1 and no vector inside the namespace ns2. And I'm also going to comment out this line because we have already deleted these vectors. So if I'll try to run it again, it is going to throw me an error. Let's run this to see if all the vectors of the namespace 2 are deleted or not. Okay, so the process finished with exit code 0. Now I'm gonna come back here and for the namespace, I'm gonna select namespace 2, but you can see that the namespace 2 does not exist because we have deleted all the vectors which were present inside the namespace ns2. So now we have only the namespace ns1 present and there are 2 vectors having ID 3 and 4 inside it. So you can see that we have successfully deleted all the vectors from a particular namespace. And you have learned a new thing from here that if you delete all the vectors from a namespace, then that namespace also gets deleted. Now let's move towards our last concept, which is of how you can delete a particular index from your project. And once you delete the index, then all the vectors and all the namespaces which are present inside the index will also be deleted. So let's see how you can do that. But firstly, I'm gonna comment out this line because we have already deleted the namespace too. Now, in order to delete a particular index, we are gonna use the Pinecone because the information about the index is stored in the Pinecone. So I'm gonna say pinecone.delete index, and inside it you have to pass the name of the index which you want to delete, which in my case is test index. If I run it now, it is simply going to delete this index from our Pinecone console. Okay, so the process finished with exit code 0. This means that we may have been successful. Let's verify it. From here, I'm going to refresh the page to see the changes. And yeah, you can see that we are inside our indexes page and there is no index available. It is simply giving us option to create an index. This means that we have successfully deleted our text index from our Pinecone. Alright, so in this video, we have learned all about setting up the Pinecone account as well as performing different CRUD operations on it. I hope that this video was very helpful for you and you enjoyed it thoroughly. Keep learning, keep enjoying.